Uh. Soleman. Recording kah? Ya, recording. Ini lebih kecilan. Gede dikit.
Hello and welcome back. In this lesson, we're going to add the SSH key to our EC2 instance to ensure we're able to connect to it when needed. What we'll do first is create the key using the AWS key pair resource, which will add it to our AWS environment, and then we will attach it to the instance using our key name attribute. So let's get started. All right, let's take a look at AWS key pair here. This is, of course, a resource. As you can see, we have a resource name, and resource instance name here. We've got to supply a key name, which can be anything we want, and then we specify the public key. Now, as you can see, this is a little long and a little ugly, so we're going to use what's called the file function to access the public key that we've created and supply it here where it's needed without having to type the whole thing out. So let's go ahead and take a look at that. Now, the file function is not actually that complicated. You can certainly go check it out in the docs, but we're just going to dive right in without spending a lot of time on that. So let's go ahead and add a few things. First things first, let's create our key pair. Now I'm going to add it right here under the random ID. So resource, AWS key pair, just like so. And we're going to name that MTC off. Open and close some braces. And we've got our key name, and we'll just name that with a variable using var.keyname. And then we've got our public key. And that's going to be file var.public key path. All right, let's go and take a look at exactly what this is returning using our Terraform console. So the first thing I'm going to need to do is create the variable we need. So I need the key name, variable key name.
Apa ini namanya? My key pair, my auth. Terus habis itu ini var key
Thing I'm going to need to do is create the variable we need. So I need the key name, variable key name, type equals string, and we actually won't specify a default here. Let's go ahead and add that. To our terraform.tf bars file. Anything security related I kind of like to leave default off of. And then let's do a variable for our public key. So public key path type equals string as well. Okay, so we have our variables. Let's head into terraform.tf bars and define.
public key path. Okay. Type equals to string.
So the first thing I'm going to need to do is create the variable we need. So I need the key name, variable key name, type equals string, and we actually won't specify a default here. Let's go ahead and add that to our terraform.tf bars file. Anything security related I kind of like to leave defaults off of. And then let's do a variable for our public key. So public key path type equals string as well. Okay, so we have our variables. Let's head in.
Oh, variabel nggak usah pakai ini ya.
terraform.tf bars and define those. I'm actually going to split this screen just so I don't miss anything here. Key name equals, and I'm just going to call mine mtc key, and public key path equals home ubuntu.ssh, and mine is mtc key. Now I'm going to verify that ls home ubuntu.ssh mtc key, just like
ls dot is now how's my key key name sama dengan my key, terus public key path nya sama dengan apa sih itu tuh? FP WD copy
like that. It is the public key path. So glad I did this. I need to remember that .pub there. So .pub, just like so. All right, now that we've done that, let's go ahead and apply, and then we're gonna hop into the console and see exactly what this file function returns. All right, as you can see, public key there was already extrapolated.
Oops. Atau guys waret. Acquiring state lock. This may take a few moments. Public key. Harto guys wareg. AWS key pair. Oh ini dia. Opsinya ada.
For us. Let's hop into file real quick and just take a look. Terraform console, file, var.public key path, just like so. And there it is. So this is exactly what's happening. It's actually
Consolas.
using a here doc right here to pull out all of the contents of our public key path file, which is mtc-key.pub. So this is how it's going to treat any file that we need to specify. So just keep that in mind. This file function is basically specifying a here doc, so it's acknowledging any type of spaces or indentation or anything else that might be in that file. So if you use the file function, it's going to extract the contents of that file exactly as they are presented. All right, perfect. So everything looks just like it should. It seems we have created that AWS key pair. It was created whenever we applied. All right, so now let's specify our key name using this resource. So I'll go ahead and uncomment.
key pair my auth ID.
Commented. And we're going to use AWS key pair.mtc auth. Now this key name actually needs to be referenced using ID. So what it's going to do is use the ID provided by this AWS key pair, which you can see here, ID is the key pair name. You can also use .key name as well. So either either one will work. It's, a little ambiguous, but either one is just fine. So you may see both. Don't let that confuse you. All right, so that's actually all we need to do there. Now, once we apply this, it's probably going to need to destroy the instance because we have added a key, and the only way to add this key to an instance is to recreate it. So keep that in mind. Let's go ahead and see if that's what happens. Yep, as you can see, our plan 1 to add, 0 to change, 1 to destroy. I probably should have planned that instead of applying first, but I got a little bit excited. Not something you should do in production. All right, all set. As you can see, we had 1 destroyed and 1 added. Of course, that is our instance. So let's go ahead and refresh this page here. And if we look at our details and scroll down, we can see our key pair name is MTC key. And this, of course, is the ID that we used to link our instance to this key. All right, so that is all for this lesson. Go ahead and mark it complete. Come on back to the next one, and let's start to play with configuring this instance to do a little more than just sit there.
Why my Wi-Fi so slow? Pak Harto guys, wah. Aduh, Pak Harto mulu tuh. Wait a second. Kok denger BBC radio? Kena itu gak ya? Kena copyright. Oh, enggak. Kok instant running-nya 0. Iyalah di Ohio, bro. Harusnya di North California. Oke, my main instance. Public key-nya di mana, kagak ada. Security. Duh, nggak ada.
Hello and welcome back.
Gimana?
This, of course, is the ID that we used to and refresh this page here. And if we look at our details and scroll down, we can see
key pair name.
Our
oh iya, my key.
key pair name is MTC.
Tuliskan kesedihan. Key pair. Oh iya, udah sini.
Key. Welcome back. In this lesson, we're going to provide some bootstrap instructions through user data that will initialize our EC2 instance with a new hostname, and then install the popular observability tool, Grafana. To do this, we'll need to provide a variable for the hostname, and for that we can use what's called the template file function and a template file. So let's get started. If you take a look at the template file function, it's actually pretty straightforward. You basically specify the function itself, template file. You then provide the path to the file itself, and then vars. Now these vars are actually going to be in a map, so they'll need to be in curly braces, and we'll see that. And then to substitute the variables within the template file, you'll use the same syntax that you use for string templates or interpolation syntax, which is the $, brace, brace. So let's go ahead and get started. First thing I want to do is create the template file. We're going to call that main-userdata.tpl, just like so. Now within that file, we're going to paste in everything that's in the user data file that I provided within the course resources. Now I want to give you a heads up, this is going to break. This is not exactly right, and the reason is not all of our commands have this -y. And the reason for this is I want to illustrate how this can go wrong, and how to update it if it does.
Terus gue harus ngetik satu-satu
Go
dong.
wrong and kind of some of the strategies around that. Of course, if you don't care to see what's wrong, you can add those -ys on any apt-get and just get it deployed and you're all good to go. But the next few lessons will kind of depend on this thing breaking. So go ahead and leave it the way it is if you're going to follow along. And let's head back over to our compute.tf there, and let's specify our user data, which is a normal attribute of an AWS instance. Let's provide the template file function, just like so.
Apa namanya? Main case. No, GitHub. DevOps in the cloud. Keren banget DevOps.
And we'll specify that file name, userdata.tpl, just like so. And then we need to specify the vars. New hostname equals, and let's go ahead and just specify our tag here. So we're going to give the hostname the same name as the tag that is specified within the EC2 console, just like so. Let's also make sure we get this in quotes. So new hostname equals quote mtc main, and then we've got our interpolated tag name here, followed by another brace, followed by our parentheses, just like so. Now, if we want to test this out, we absolutely can. Go to Terraform console. We're going to have to make a little bit of an adjustment because, again, Terraform console does not have access to count.index. But I'm just going to copy this whole thing, place it in here, and where there's the count.index, let's just hardcode that to 0. And as you can see, I've got the wrong file name there. Main-userdata, sorry about that. Let's just press up. And main dash, just like so. There we are. So now, as you can see, sudo hostnamectl set hostname mtc main 54685. All right, perfect. That's exactly what we're looking for. And once again, just like the file function, it does a here doc syntax, and everything is exported exactly as it's found in the file. All right, perfect. I'm glad we went over that because we caught that error right there. That's a great reason why the Terraform console is incredibly useful. All right, so now that we've done that, let's go ahead and run our plan. Now, since user data is being changed, it's going to have to destroy our instance and rebuild it. As you can see, we want to add 1 to destroy. And the user data here, as you can see, which is specified here in an encoded format, forces replacement. So that's how you can tell what is causing the destruction of our instance. All right, so go ahead and run a Terraform apply, auto approve. And again, this is not going to work. So I want you to go ahead and apply it, but you can go ahead once you've applied, mark this lesson complete, and come on back to the next lesson. And by then, hopefully everything will have applied.
Enclave. MTC main stance dollar 장가지 등가지 dollar 사랑게 등가지 yolo yo la Cangcimen oops Terraform plan gọi từ tầng gọi good life is on the way. Want to change 0 to destroy.
And we can take a look at what exactly is going wrong and how we might adjust for that. All right, so mark this.
1 to add, 0 to change, 1 to destroy. Kok gue cuman okay.
This lesson complete. Come on back and let's continue the course.
grafana.
Hello and welcome back. So, I wanted to apologize again for leaving you on a little bit of a cliffhanger from the last lesson, but you know me, I love to build that suspense. So in this lesson, I'm going to go and show you what exactly went wrong, because you may not have noticed yet, and how you might want to fix that. So let's get started. Alright, hopefully between lessons you've given this time to apply, all the resources to deploy, and hopefully the EC2 instance we deployed has given us some information. So within my EC2 instances, I've got the MTC main here once again. Now what should happen is we should be able to hit port 3000 and see Grafana, but obviously that's not working. So let's go ahead and run down to monitor and troubleshoot after right-clicking on that instance and get system log. Now you should have a log here. This can take anywhere from 3 to 5 minutes, maybe even longer, but hopefully you have your log here, and if you don't, feel free just to watch along. This isn't super important that you have. So I'm just going to search for Grafana, and this is where that user data started kicking off. So as you can see, everything, some of the stuff is already installed, all that's fine. I'm going to scroll down, and here we go. Do you want to continue? Yes, no, abort. As you can see, it basically hung there and timed out. It did not actually get to installing Grafana because within our user data, we did not give it permission to with the -y. Now this is one of the really annoying things of user data and Terraform provisioners. Now if you've been paying attention, obviously you know Ansible's coming up. You might be getting a little bit of a hint now as to the point I'm getting at. However, right now we're going to focus on Terraform, and eventually Ansible's going to solve some of these issues. But for right now, we know that there was a problem. We know that we didn't give Grafana permission to install, and it caused, without telling us anything at all, it caused our instance to not bootstrap properly. So what we can do is head into our user data here, and just go ahead and provide the -ys that we need to provide. So before our update, I'll add a -y. I'll add a -y before Grafana, just like so, and that should fix the problem.
Udah bener udah.
So how now are we going to just redeploy that EC2 instance without deploying everything else again? We can use the Terraform taint command. So what we can do, let's do a Terraform state list real quick, and bump this up a little bit. As you can see, we've got AWS instance.mtc main, and then of course index 0. So what we want to do is use the taint command to tell Terraform that this is now an invalid resource and it needs to be redeployed. So let's do that. And this is kind of how you could redeploy an instance for any reason you might need to. But of course, changing user data is a pretty good reason to have to redeploy an instance. Now I do want to mention that you don't always have to use the taint command. User data itself will actually be detected by Terraform because it is encoded. So if I run a Terraform plan here, as you can see, the hash of the user data has changed, so that forces a replacement. So in this case, you don't necessarily have to use the taint command, but this is a really good chance to show you that. So let's once again do our Terraform state list. And once again, you can see we've got AWS instance MTC main index 0. I'm just going to copy that. Let's run a Terraform taint and just add that in. Okay, resource instance, AWS instance MTC main has been marked as tainted. Perfect.
What is
So now if I
taint? Taint. No, that tainted.
Terraform plan, it is also going to destroy that instance. Now, of course, because this instance was tainted, it tells us this is tainted, so must be replaced. So it doesn't care that the user data hash here has changed. All it cares about is that it's been tainted, so the whole thing is getting replaced. So let's go ahead and run our Terraform apply, auto approve.
Terraform apply auto. Oops. Bismillahirrahmanirrahim.
And let's make sure that Grafana comes up this time. Once again, this will probably take 3 to 5 minutes. Go ahead, go get you some coffee, whatever you need to do. Come on back, and we'll see if everything works. Alright, so the apply.
Aduh lah, break dulu. Kayaknya lama banget. Bye-bye. Oh, udah jadi? No, break dulu. Bye-bye. Oke, kita coba buka websitenya. Sini. Sini. Hop. Aku nggak mau. Sini. West Ohio, Mountain Mama, country roads, take me home. Public IP-nya di almost heaven. Oops, ini dia.
Come on back to the pretty cool. So go ahead and mark
3.000. Bismillah. Nggak bisa dong, kampret. Kan udah running. Open address. Lah kok nggak mau sih?
So that means that the bootstrapping is probably not complete. I'll go ahead and at least set this up and see what happens. Okay, look at that.
Mau. Oh jangan TTPS. Wah nih ya udah semua ya. Seperti itu. Kenapa nggak mau jalan? Apakah ada 18? It's always happening like this every single fucking time. Kok root table association-nya apa? Research 20 malah. Table udah ada kok, root table my perfect. Kenapa nggak mau ya? Bukan benar kan? Shared issue. Set cannot be reached.
Already complete? Comes up this time. Once again, this will probably take 3 to 5 minutes. Go ahead, go get you some coffee, whatever you need to do. Come on back, and we'll see if everything works.
Networking issue ya berarti ya. Chrome Astagfirullahaladzim. DNS hostname kita cobain aja. GitHub. Di mana nih bagian Terraform di ini sih. Coba kalau sekarang ngeliat
Hello and welcome back. Provide instance with a new host name, and then alright, perfect. That's exactly what we're looking for. And once again, just it does a here doc syntax right there, that which is specified here. And alright, Terraform, and eventually Ansible is going to solve some of these issues. But go ahead and run down to monitor and troubleshoot after.
Monitor and troubleshoot. Oke, kita coba monitor and troubleshoot.
Right clicking on that instance and get system log. Now you should have a log here. This can take anywhere from 3 to 5 minutes, maybe even longer. But hopefully you have your log here, and if you don't, feel free just to watch along. This isn't super important that you have. So I'm just going to search for grafana. And
ya aku nggak ada grafananya sih. Nah iya, gimana dah? Kok dia nggak nge-bootstrap ya? Aneh banget. Nggak ke-install anjir. Kok dia nggak nge-bootstrap? You can't always get what you want. Security group rule coba. Inggris 65. Apa yang ngebuat ini nggak bisa nge-bootstrap? And I was what the fuck? Compute. Kayaknya nggak ngaruh deh, cuma begini doang. Apaan sih?
And this is where that user data here in an encoded format for oh, there we are. So now, as you can see, but I'm just going to copy this whole thing, place it.
Ini apa sih, kan copy udah. The character is not within the language.
In here and to file name there, main-user data. Sorry about that. Let's just press up. And main dash, just like so. There.
Zero. The character is not used within the language. What? apa di sini lah, template file slash main user tpl, koma new host name. Cupras capres reference to count. Iya, tipe berarti bener aja. Apa ya yang bikin tipe ya? Coba ya. Apa yang bikin tipe, brother? Sama aja, cuk. Apa ngebedain, cuk? Main user dari aneh anjir. Sama aja. Supra capres. Ada isinya tadi berarti. Ya nggak bakal ada yang berubah sih. Nggak bakal ada yang berubah. User datanya berubah nggak? Bentama user data nggak? Oh, want to change. Oke. Berarti benar. Will be update. ID sama teksnya doang anjir.
Eventually, Ansible's going to solve some of these issues. But for right now, we know that there was a problem. We know that we didn't give grafana permission to install, and it caused without -y before it's grafana terraform. And pump this up a little bit. As you can see, we've got AWS instance.mtc main, and then of course index 0. So what we want to do is use the taint command to tell Terraform that this is now in invalid resource and it needs to be redeployed. So let's do that. And this is kind of how you could redeploy an instance for any reason you might need to. But of course, changing user data is a pretty good reason to have to redeploy an instance. Now I do want to mention that you don't always have to use the taint command. User data itself will actually be detected by Terraform because it is encoded. So if I run a Terraform plan here, as you can see, the hash of the user data has changed, so that forces a replacement. So in this case, you don't necessarily have to use the taint command, but this is a really good chance to show you that. So let's once again do our Terraform state list, and once again, you can see we have AWS instance mtc main index 0. I'm just going to copy that. Let's run a Terraform taint and just add that in. Okay, resource instance, AWS instance mtc main has been marked as tainted. Perfect. So now if I run a Terraform plan, it is also going to destroy that instance. Now, of course, because this instance was tainted, it tells us this is tainted, so must be replaced. So it doesn't care that the user data hash here has changed. All it cares about is that it's been tainted, so the whole thing is getting replaced. So let's go ahead and run our Terraform apply, auto approve, and let's make sure that Grafana comes up this time. Once again, this will probably take 3 to 5 minutes. Go ahead, go get you some coffee, whatever you need to do. Come on back, and we'll see if everything works.
Bismillahirrahmanirrahim. Break dulu bentar. Grafananya berhasil. Jadi tadi ya memang masalah itu ada di user data ini sih. Dan setelah dilihat di ininya apa namanya log details itu ada kesalahan pada saat ini nih template file. Jadi bukan masalah di security group tapi kesalahan di bootstrapping user file. Oke, jadi ini admin. Oke, passwordnya ini aja lah. Jangan. Wih, masuk man. Damn, never. Oke, Grafana sudah berhasil terinstall. Lanjut lagi.
Alright, so the apply is all complete. Let's take a look in our EC2 instances here and make sure everything looks like it's up. As you can see, still initializing. So that means that the bootstrapping is probably not complete. I'll go ahead and at least set this up and see what happens. Okay, look at that, already complete. If I type admin, admin, and then type a new password here, we are into Grafana. Alright, so we finally got our EC2 instance doing something pretty cool. So go ahead and mark this lesson complete. Come up.
Ini kita kasih tanda dulu. Ini berarti bootstrapping Grafana. Make sure template file is not typo. Okay, let's go.
On back to the next one, and let's do a few more things before we move on. Hello and welcome back. In the last lesson, we bootstrapped our instance with Grafana using user data, and in this lesson, we want to run a script locally on this server to export the IP addresses of the instances that are created. Now, of course, we only have one instance, but if we had multiple, we would also want those exported, and we want these IP addresses exported to a file. Now, it's not super useful yet, but I assure you in the future you're going to see why this is very useful, especially once we get to Ansible. So how are we going to export an IP address to a file on this local server? Well, we can use what's called a provisioner. A provisioner allows us to run an arbitrary command and locally for the IP we get to Ansible. So how are we going to export an IP address to a file on this local server? Well, we can use what's called a provisioner. A provisioner allows us to run an arbitrary command locally using the local exec provisioner or remotely using remote exec. In this case, since we're looking for a local file, we're going to use the local exec provisioner. Now, we can use the local exec provisioner to run any command on the local system that we want, whether it's a simple echo, cat, printf, sed, etc., or perhaps even scp to pull something from a remote server. Now, provisioners themselves are generally discouraged in Terraform because their outcome is not recorded in the state. So if the command is not idempotent, meaning that it will have different results if it's run more than once, that can cause all sorts of issues if you don't know the state of the current system. Now, we're going to dive a lot more into that as we go into the Ansible sections, but for now, just know that provisioners should be used as a last resort or only for ephemeral or extremely simple workloads. And that is all covered, of course, in the docs. But anyway, after that long batch of advice, let's go ahead and ignore all of it and create a local exec provision. So as you can see here, we've got the docs, and basically all it is, we specify it within a resource, and we just run a command. That's all. Now, there are a few other things you might want to specify, especially if you're using Windows and you want to specify a PowerShell interpreter. We're not going to cover that here, but just know that that option is there. And then, of course, we also have the main provisioners page here. Not a lot there, but if you go through the docs, you're going to get a lot of extra information. And we're going to cover some of it, but for the most part, we're going to keep it very simple, again, because provisioners are not heavily recommended at all. So let's head back over, and let's add a provisioner. So we're going to add that within our AWS instance resource. So basically what's going to happen is anytime this resource is created, the provisioner is going to run. So let's add provisioner, and again, make sure you are within the confines of this instance. Provisioner, local exec. Now I want to point something out here. Underscore, 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 underscores everywhere. All of the Terraform stuff all has underscores, except local exec, remote exec, etc. Provisioners have hyphens. Keep that in mind. I've made that mistake literally hundreds of times. I guarantee you're going to do it at least once. So try to keep that in mind. Let's wrap that in some braces, and let's specify a command. So what we want to do is we want to create a file. We're going to call that AWS underscore hosts. So basically a list of host IP addresses that we acquire from these instances. And then for the command, now you can use the file function if you want, but we're just going to specify this inline. We're just going to say printf, and we want to create a new line. And here is some of the magic of a provisioner. Provisioners get the luxury of using the keyword self. Now you may have used that in other programming languages, but the keyword self allows us to reference this resource without having to specify count or any other weird attributes to ensure we have the right one. So every time an instance is created, it will reference self to get its attributes. So what we want is just the public IP, just like so, and we want that exported to AWS hosts, just like that, in a file called that. And we also need some single quotes here around what we're going to pass into the printf command, just like so. Now the other thing we need to do is we need to create this AWS host file. So let's create a new file, AWS underscore hosts, just like so. Let's open that, and at the top, just add a bracket with servers inside of it. And this will all make a little more sense why we're doing it this way once we get to the Ansible section, but for now, just go ahead and create this. And before we run this, let's make sure that everything looks right by running that command on our system. So we're just going to do printf, add that new line, self.public. Actually, you know what? Let's just say 10.100.4.10 or whatever. We'll just make up an IP address there and send that to our AWS hosts, and let's make sure that this works. AWS hosts, perfect. So that's going to work, and that's essentially what it's going to look like whenever we run this command, only self.public IP is going to be replaced by the public IP of. The instance itself. All right, so perfect. So now let's go ahead and run a plan and see what happens. Look at that, no changes. So this is a very important aspect. Of the right, so perfect. Placed by the public IP. of the instance itself. All right, so perfect. So now let's go ahead and run a plan and see what happens. Look at that, no changes. So this is a very important aspect of the provisioners. Terraform essentially is going to ignore them. You can change a provisioner all you want, but it's not going to redeploy an instance just because you changed a provisioner. So keep that in mind. That's very important to know, and that's one of the reasons that provisioners can be annoying, but also can prevent your entire infrastructure from being destroyed due to the change in a script here. So do keep that in mind. So what we're going to do to utilize this provisioner is we're going to taint this AWS instance again and reapply. Terraform taint, AWS instance, .mtc main, and of course we use the index of 0 since there is one there. All right, all tainted. Let's run this Terraform plan again. All right, one to add, one to destroy, just like we expected. So now everything is right. The instance is tainted, so it must be replaced. So let's go ahead. Ahead and apply this. Alright, as you can see here, local exec executed and substituted the IP address properly. Let's see if it worked. Boom. Perfect. So we got exactly what we were looking for there. Everything looks good. Go ahead and mark this lesson complete. Come on back to the next one and we're going to see how to undo what we just did.
Wah, lu ngapain lu?
Hello and welcome back. In this lesson, we're going to create what's called a destroy time provisioner, which will essentially undo what we've done here. So as you know, we've appended an IP address to the bottom of this. Well, whenever we destroy that instance, we don't need that IP address here anymore. So what we can do is create another local exec provisioner, and we specify the when attribute. And if we specify that, that allows us to say when destroyed, then run this provisioner. So let's take a quick look.
When destroyed,
Local
when
exec
destroyed.
again. And this time, when equals destroy, just like so.
When.
And then we need to provide our command. Now, in this case, we're going to use a sed command. Now, of course, this is not Terraform specific. This is a very common Unix and Linux command. So sed -i, which means that the operation we're going to perform is going to be in place. It's going to modify the file that we are working with. And then we'll do a single quote here, provide a slash, and we're just going to provide that caret there. And after that, we want to specify that we want to delete any line that begins with a number. And this is regex that I'm using here. If you're not familiar with it, I strongly suggest you at least do a little bit of research on it. So we're going to specify brackets, and basically any line that starts with 0 through 9 is what we're going to process. We'll add another slash and add a D, which means we want to delete that line. Now let's close that off with a single quote, and we will specify the file name, which is AWS hosts, just like so. And that's all there is to it. Just a black 0 on a line. After that, we want to specify that we want to delete any line that begins with a number. and this is regex that I'm using here. If you're not familiar with it, I strongly suggest you at least do a little bit of research on it. So we're going to specify brackets, and basically any line that starts with 0 through 9 is what we're going to process. We'll add another slash and add a b, which means we want to delete that line. Now let's close that off with a single quote, and we will specify the file name, which is AWS hosts, just like so. And that's all there is to it. Alright, so now we've got our destroy provisioner ready to go. Now, as you know, typically about this point, I might want to taint this resource and reapply. Well, let me show you a little something that might change that idea. As you can see, a destroy time provisioner within a resource that is tainted will not run, so we cannot do that. So very unfortunately here, we've got to delete everything just to have this destroy provisioner run. So as you can see, we've got our servers, we've got our IP address there, so let's go ahead and destroy everything. Now if I open my AWS hosts, as you can see, now that everything's being destroyed, the IP address is gone. But once again, tainting and reapplying will not work. You have to run the terraform destroy command for a destroy provisioner to be run. And that's one reason why, honestly, destroy provisioners are pretty heavily discouraged, especially if they're going to do anything very productive. Now, if it's just something like logging or something, you might be able to be fine with it. But if this is something that is incredibly important for production, you probably don't want to use them. That being said, let's go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to get our Cloud9 instance set up with a static IP address, and then we're going to add that static IP address to our security group to ensure that we have access to all of our resources from our Cloud9 instance as well as from our home computers. So let's go ahead and get started. First up, let's head up here and click on this little icon here and manage EC2 instance. I'm going to center click on my mouse to ensure I open another window. And I've got my instance right here. So what I want to do is click on Elastic IPs right here, allocate Elastic IP address. We want to keep it in US East 1, at least that's where I'm located. I'll add a tag, name, Cloud9, so that I remember which one this is attached to, and allocate. Alright, and once I have done that, I'm going to click on Actions up at the top, associate Elastic IP address, choose Instance. As you can see, I've got kind of a lot of stuff going on, but this is the correct one here, AWS Cloud9 MTC to Ansible, which is the name of my Cloud9 instance. So I will choose that, and I'll allow it to be reassociated, although I don't see that happening anytime soon, and associate. Alright, perfect. So now what I'm going to do is just copy this IP address, just like so. Now I'm going to head to my instances page here, and as you can see, the IP address does not match currently. If I go back, I can see 54.86. So what I'm going to do is just reboot this instance. And once you've rebooted it, again, it may not be absolutely necessary to reboot, but this way we know for a fact it's going to work out the way we need it to. Go ahead and close the terminal that we had open. Just close it. Make sure you've saved all of your files, of course, first, and reopen it, just like so. And once you've done that, everything should be back and ready to go. So next up, going to change directory back into our working directory, and let's add another variable. Let's go ahead and I'm going to add it under my access IP variable, Cloud9 IP, just like so. Within that, type equals string once again, and default equals and let's paste in our IP address right there, the new elastic one, and /32, which indicates we just want that IP address, .cloud9 IP, just like so. Groups, and in here we've got the public SG security groups, and once that's done, you can see our source right here has added our new IP. So that's everything for this lesson. Go ahead and mark it complete. Come on back to the next one, and let's continue the course. Let's run a Terraform apply auto approve instance. Hello and welcome back. In the last lesson, we took a look at the local exec provisioner and its behavior when embedded within a resource. Now, what if we want to make some modifications to that resource after it's been deployed? Either we don't have user data, we have something custom that won't run within user data for some reason, or perhaps we want something to run outside of user data and local provisioners, and perhaps after a resource has been deployed. Now, typically, we don't want to be modifying resources after they've already been deployed. We want those resources to be immutable. In other words, we should be modifying the resources in code and redeploying them, but sometimes budget, availability concerns, legacy systems, or just improperly designed systems can prevent this. So unfortunately, this isn't a perfect world, this is the real world, and not everything goes as planned. So let's take a look at how we might use a remote exec provisioner to update an instance in place without any downtime. And again, using provisioners is not recommended in most circumstances, but it will help you see the path to Ansible, and of course give you a nice easy way to run commands on your less than production workloads. So let's get started. Let's take a look. We've got the remote exec provisioner here. As you can see, pretty straightforward. Instead of the command directive here, we're just going to use inline, which means that we just want to run an inline script. You can also pass in the script argument here, or even scripts, but we're going to keep it simple. Again, we're not going to dive too deep into these provisioners because that's not the preferred way to go. Now, to connect to this instance, we've got to provide a connection block. And as you can see, we can pass in an SSH connection. So SSH, root, we can pass in the key, all of that, and that's how we're going to connect to our instance. Now, since this remote exec provisioner that we're going to deploy is not going to be deployed within the instance block, the self object is not going to work, and I'll show you what I mean here very shortly, as in right now. So we want this remote provisioner to run outside of the creation of the instance. So that means we don't want it embedded within the instance, we want it to be its own resource. So how do we create its own resource? Well, we use what's called a null resource. So resource, null resource, and this is actually a resource, so you do have to run another Terraform init, and let's just call this grafana update, just like so. Now we're going to need to run this on every instance that's created. Now again, even though we have an instance count of 1, we still need to specify that count, just in case we scale it up, and because there is an index of 0 already. So let's provide our count, and that's going to be var.main instance count. We can use that because we want it to run on every instance. Our provisioner is going to be remote exec this time, and again, we're embedding this provisioner within this null resource. This null resource can be tainted, applied, destroyed, etc. It's treated just as any normal resource. So let's open and close those braces. Let's provide our inline argument there. And now what I want to run is sudo apt upgrade -y grafana, and then just for the heck of it, let's add an upgrade log, just like so, and we'll keep it very simple here. And echo I updated grafana, and let's send that to the upgrade log. And I'll be polite and capitalize grafana as well. Alright, so what we're going to do is upgrade grafana, we're going to create an upgrade log, and then we're going to echo I updated grafana into that upgrade log. Alright, so now let's tell this how to connect to that instance. So we'll just provide the connection block, just like so, type equals SSH, user equals Ubuntu, just as if we're SSHing into the instance, private key. Now we'll use the file function here, home ubuntu.ssh /mtc key, just like so, and this is not the public key, this is the private key, this is what's going to be used to access that instance. And now the host. Now remember, we cannot use the self argument here, we have to access the instance by its IP address provided outside of the AWS
Wah,
instance.
kampret. Cuman ngedestroy aja lama banget. Emang internet paling terbaik di dunia. Sebentar ya. Nessun dorma, tu pure principessa, na. Guardi le stelle che tremano di amore e di speranza. Ma il mio mistero è chiuso in me. Il mio nessun saprà, no, di lei buonanotte, la dirò quando la luce splenderà. Ini gimana sih? Ya, operation cancel aja gua. pause dulu karena destroy lama banget. Let's go. Berarti errornya tuh bener di sini ternyata, karena di sini internet gateway-nya cuma 2 menit doang dibutuhin. Tadi bisa sampai berlaut-lautan banget. Perasaan ya, ntar kita review lagi.
Hello and welcome back. Instance block. So AWS instance.mtc main. Then we need that count.index.public IP, just like so.
Apa ya? Terraform. Ini bisa jadi passive income sebenarnya, terus Udemy gini. Lumayan banget. Shout out lah untuk orang-orang yang keren-keren. You guys are freaking awesome.
So now every instance that is created will of course have this script run on it based on its index. And now what I'm going to do, we've got a lot of indentation and a lot of stuff going on here. I'm going to run another fun command called terraform fnt, and that cleans everything up nicely for us. Then let's run a terraform init to ensure we initialize this new null resource. All right. So now let's go ahead.
Private key. Private dan private key. Wah, ini pelajaran nih. Oh ini ya, ini di AWS main provider. Oops. Ini ya public key path. Oh, public. Okay.
And run our terraform plan. Of course, everything needs to be rebuilt because we destroyed it in the last lesson. So let's go ahead and terraform apply and build everything again. All right, so we got some red here, which is very unfortunate, but this is exactly one of the reasons why provisioners can be a huge pain. As you can see, it took a little bit of time to connect. Basically, it tries and tries and tries until it connects. And then we get it connected right here. All right, and script started to run, look at that, but check this out, unable to locate package grafana. Now the problem with this is, basically all the user data has not run yet, so this wasn't even ready to go. So what we can do is we can start to add all sorts of extra scripts to check for the existence of grafana before we run it and all of that, but as you can see, this can be a gigantic pain. So anyway, let's go ahead and check to see if grafana is running yet. Look at all these instances during my testing. You can ignore most of those. And the old grafana we had up, let's go ahead and replace that with this. Alright, Grafana is up now. So let's go ahead and taint this null resource and rerun. So terraform taint null resource dot grafana update. And then we've also got to specify that index. Remember, we used count. So if I run terraform state list ref null resource.grafana update, just like so. So once again, terraform taint, and I'll just copy this and paste it like so. All set. So now let's run a terraform apply auto approve and see if things work a little bit better this time. All right, look at that. We're getting a lot more than we did before. Perfect. It looks like everything worked well. Let's go ahead and SSH into this instance. So SSH-I Ubuntu at and that IP address. All right, we're all logged in. ls, look at that. We've got our upgrade.log. I updated Grafana. So perfect. It looks like everything worked
Tereng deng 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 dereng. Tereng bap 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 bap. Wisnur Patria anjir.
very well there. Again, we just had to wait until Grafana finished bootstrapping, and unfortunately, it had not yet. Now, there are ways around that, but we're going to dive a little more deeply into that as we move into the Ansible section, coming up very, very soon. So go ahead and mark this lesson complete.
Oke, kita masuk ke
Hello,
juga
and welcome
dipakai.
back. In this
Nggak
lesson,
apa-apa.
we are going to install Ansible. So there are lots of different ways to install Ansible. Now, we'll be using the app method to install it. You can also use Python's pip package manager, and of course, depending on your OS, there are a lot of other options here. Now, depending on your production requirements, you may want to prefer pip, or you may need to freeze Ansible to a certain version. But with us, we're going to keep it as simple as possible and just get it installed. So first, what we want to do is update our apt cache. So we'll run sudo apt update, just like so. All right, perfect. Now, after that, although we already have with our Terraform installation, we're still going to ensure that software properties common is installed. So let's go ahead and run that sudo apt-y install software properties common, just like so. All right, perfect. Now we need to install the Ansible repository. So sudo add apt repository -y-update ppa:/ansible/ansible, just like so. Alright, all set. And now finally, let's install. Sudo apt-y install Ansible.
Kala kanca priya wanita nananane syariat bloko. Tereng teng tong tong terong teng. Kita harus menang total. Kernel step, what the hell is kernel step?
Alright, perfect. So let's make sure that worked. Ansible -- version. Alright, perfect. Ansible 2.9.27. And again, you may see some newer versions that we're not using in this course. Ansible doesn't move like HashiCorp's Terraform does nowadays. There might be a few updates here and there, but for the most part, this is a somewhat foundational to intermediate Ansible course, so we're not going to be deep diving into some of the crazier fringe Ansible features. Everything we do is something you are probably going to run into at just about any company. So, Ansible is installed. Feel free to go ahead and mark this lesson complete. Come on back to the next one, and let's start using it.
Ad hoc comments.
Hello, and welcome back. In this lesson, we're going to dive into Ansible and start simple by exploring ad hoc commands. Ad hoc commands are commands that you can run if you need to perform quick actions that may not require a full playbook, which we'll be writing very soon. Now, these commands could be used to ping hosts, check for connection, reboot hosts, restart services, etc. I generally recommend trying to avoid ad hoc commands that modify the system, as they, like any bash command, can be very dangerous if run carelessly. But they can be very useful in emergency situations where changes need to be made quickly, such as during a cyber attack or other time-sensitive events. In general, playbooks, which again we'll be covering very soon, are the best way to make any system modifications. So with that little warning out of the way, let's get started. So you can actually take a look at the docs, and there are a lot of examples of ad hoc commands. We're going to cover some of them, but for the most part, as I said, this course is about playbooks. This course is about running everything in automation, and ad hoc commands just are not a way to perform automation, especially if you can avoid it. So let's run a few just to get a feel for Ansible. First up, let's start with the most simple one, and this is one you might use quite frequently, and that is the ping command. Ansible, localhost, and of course localhost is what we're on, -m ping, just like that. As you can see, it is successful. Now, this doesn't mean we just had networking connectivity. This means that Python is ready to go, and Ansible is ready to perform actions on this machine. So again, this isn't just a network test, but this tests more than that to ensure that Ansible is good to go. And it appears that it is. Now that M that we used, that stood for module, just so you know. So now let's try a simple shell command. Let's just run a ls and see what's in this directory. So we can do Ansible localhost -m for module shell -a, and then we'll have to quote this bin ls, just like so. Okay, now perfect. You can also run that without this module specified. You just have an A there, which stands for module args. It will do the same for us. So now let's run something, I don't know, that does a little bit more. We can also run echo, we can run other commands as well. So for instance, Ansible localhost, run echo. Now let's run module arg. Enjoy the fact that you've got a nice, wonderful new Grafana instance to play with. Maybe go in, poke around a little bit, see if you can find some interesting things to do, but then make Hello and welcome back. In this lesson, we're just going to expand our Cloud9 disk image just a little bit over the course of our resource tab, head to the course resource, and then let's just go ahead. Let's open that up. And let's you hit plus tab. Look, right now we've got 20 GB free. So this being 20 is fine. Other passes have a lot of other and run. As you can see, everything looks good. Change partition. Don't have to worry about that. This script. And if you run an LSDLK, so that's lit. Come on back to the next one and let's continue the course. Args, it will do the same for us. So now let's run something, I don't know, that does a little bit more. We can also run echo, we can run other commands as well. So for instance, ansible localhost, -a, then echo, hello. Notice how I use single quotes here. So obviously quoting rules are very important. Make sure that you follow any quoting rules for the shell that you're using, which again, you're probably using bash or maybe CSH, but for the most part, they're going to be similar. All right, so now let's do something a little more productive. Let's install nginx. Now what we're going to use is the ansible.builtin.app module here. Now you can just specify app, but Ansible built-in has been added to the documentation, and I just recommend that you do things as deliberately as possible with Ansible, so we'll be including that with all of our commands. Now as you can see, there's a lot here. We've got auto clean, auto remove, a lot of the same commands you see with the apt command. So let's go ahead and run this and install nginx. So ansible localhost -m for module once again, ansible.builtin.app -a, and then we're going to provide the name of the package we want to install, nginx, and then the state of that package that we want, which in this case we want it to be present. So keep that in mind. This is a declarative language, which means we tell it what state we want, and it makes sure it's so. So if we have multiple machines and some have nginx already, it's not going to run this again. If it's already present, it doesn't need to run the command again, so it'll save you a lot of time and overhead, which is great. That's one of the wonderful things about Ansible. And if I change the state to absent, well, it will remove it if it's there, but it's not going to run the command if nginx isn't already installed. Now we're going to get an error with this, but I want you to see it. All right, there we go. As you can see, failed, permission denied. So as you remember, to use apt, you've got to run as a sudo user, and we did not become a sudo user. So what we need to do is become one, and to do that, we add the keyword become, just like so. All right, check that out. We now keyword become, just like so. All right, check that out. We now have nginx there. It looks like it's been installed. Setting up nginx, as you can see. Let's take a look. Nginx service loaded is there. Now, we haven't actually run it or anything like that. That's something we will start playing with once we get into playbooks. But as I said, we're not going to focus too much on the ad hoc commands. So now, let's remove it. Just press up a few times here. Change this to absent, and removing nginx, just like we asked for. Alright, so that's pretty... Just press up a few times here. Change this to absent, and removing nginx, just like we asked for. Alright, so that's pretty much all we need to cover for the ad hoc commands. Again, we're going to spend a lot more time in playbooks, but keep those in mind because they can be very useful if you need to check for quick statuses of systems or perform quick operations. But anyway, go ahead and mark this lesson complete. Come on back to the next one, and let's continue the course. Hello and welcome back. In this lesson, we're going to start building our Ansible inventory. Now, Ansible, of course, can be run manually by just specifying a host, but that kind of goes against the entire idea of Ansible, which is a way to run the same command on tens, hundreds, or even thousands of hosts simultaneously. So let's take a look. Now, as you remember before, we were just running ansible localhost -m ping, like so, to run this command on our local host. So now let's go and add that localhost to our host file. What I'm going to run is a sudo vim etc ansible host, just like so. And this is the default Ansible host file, or inventory file. Now there are a lot of potential ways to organize this file, but we're going to keep it simple first, and we'll kind of iterate through this as we go through the course. First up, all I'm going to do is just add localhost. And basically what that's going to do is give us a host named localhost that's accessible on localhost, which of course 127.0.0.1. So let's go ahead and save 0.0.1. So let's go ahead and save that. And now, let's run ansible localhost -m ping and see what happens. Okay, as you can see, it's actually asking us if we want to continue connecting now. So what's going on here? As you can see, it's connecting over 127.0.0.1. And before it worked just fine. Ansible localhost, of course, 127.0.0. Add local through this as we go through the course. First up, all I'm going to do is just add localhost. Default Ansible host. Go and add that localhost to our host file. So what I'm going to run is a sudo vim etc ansible host, just like so. And this is the default Ansible host file, or inventory file. Now there are a lot of potential ways to organize this file, but we're going to keep it simple first, and we'll kind of iterate through this as we go through the course. First up, all I'm going to do is just add localhost. And basically what that's going to do is give us a host named localhost that's accessible on localhost, which of course 127.0.0.1. So let's go ahead and save that. And now let's run ansible localhost-n ping and see what happens. Okay, as you can see, it's actually asking us if we want to continue connecting now. So what's going on here? As you can see, it's connecting over 127.0.0.1. And before it worked just fine. When you don't have localhost in your inventory file, it uses a special alias to localhost and basically has all the settings set up for a local connection. Now we can set that up manually. First thing we want to do to help prevent this here, which can be a big problem when we're trying to run things in automation because we can't pass in this yes or no. So I'm going to just Control-C this. We can change the configuration of Ansible to ignore that warning. So what we can do is run sudo vim etc ansible ansible.cfg, just like so. As you can see, there is a lot going on here as well. There are a lot of defaults that are pretty sane. Ansible's set up pretty well. But there are also ways you can potentially optimize your deployments. So like, for instance, if you use the same key every time, you can actually specify a default key here. There are a lot of different ways to optimize your deployment. But right now, what we are most concerned with is that connection rule. So what I'm going to do is type / right there to start my search. Just type host_key, just like that, and hit enter to start on this line. I'm going to press I and delete.
Local connection risk.
That hash right there to uncomment. And now we have set our host key checking to false, just like so. If yours were to say true here, you just change it to false. Then hold Q to save, just like so. And now let's try that command again. Press up a few times. Okay, so we're a little closer now, but we're not quite in, and the problem here is we're getting denied due to our public key. So what we need to do is head back into our host file here, etc ansible hosts, and we're going to add a configuration variable here, and we're just going to add it in line for right now. So if you don't have any headings and you just have localhost listed or one host listed or something like that, you can just specify the variables in line. So in this case, ansible connection equals local, and this is one of the default configuration variables that
Bener ya,
wants
dia.
defined for rectangle or key. Right now, WQ to save. The false. I'm going to press underscore key. Types is that demise matches for cf sudo vim etc ansible ansible.cfg. Just like so. As you can see, there is a lot going on here as well. There are a lot of defaults that are pretty sane. Ansible's set up pretty well. but there are also ways you can potentially optimize your deployments. So like, for instance, if you use the same key every time, you
It
can
does
specify a
guys.
default key here. There are a lot of different ways to optimize your deployment. But right now, what we are most concerned with is that connection warning. So what I'm going to do is type / right there to start my search. Just type host _ key, just like that, and hit enter to start on this line. I'm going to press I and delete that hash right there to uncomment. And now we have set our host key checking to false, just like so. If yours were to say true here, you just change it to false. And then :Q to save, just like so. And now let's try that command again. Press up a few times. Okay, so we're a little closer now, but we're not quite in. And the problem here is we're getting denied due to our public key. So what we need to do is head back into our host file here, etc ansible hosts, and we're going to add a configuration variable here, and we're just going to add it in line for right now. So if you don't have any headings and you just have localhost listed or one host listed or something like that, you can just specify the variables in line. So in this case, Ansible connection equals local. And this is one of the default configuration variables that Ansible recognizes. All right, so let's do that, and let's try again. Okay, we're connected, but we still have this nice little deprecation warning. Now, as you can see, distribution Ubuntu 18.04 is using Python 2 and not Python 3. If you're not on 18.04, you may not have this problem. Since we're on 18.04, we're using an older version of Python, and we don't like that. Luckily, there is a way to fix that as well with another default configuration variable. So let's head back into our host file. And you won't have to do this for every instance that you work with, only the ones that are defaulting to Python 2. And let's add Ansible Python interpreter equals USR, then Python 3, just like so, which is what we saw in our error message. We scroll up, you can see USR, then Python 3. So now let's try this one more time. All right, we've got rid of all of the errors. How about that? So everything works, but honestly, I don't like the way our host file looks, especially if we've got to manage lots and lots of hosts and lots of groups. This is a little bit ugly. So let's go ahead and clean this up a little bit. What we're going to do is add a bracket here. Just include hosts in this. Basically, hosts is the name of this group. It's not a reserved word or anything like that. We're just naming this group hosts. And then what we want to do is add our variables below that. So hosts, vars, just like so. And then we want to just move this to a different line. And now let's give this a shot. Hey, perfect. Now, let's give this a shot. Hey, perfect. Perfect. And like so. Now, Hey, perfect.
45 dulu deh.
Hello and welcome back. In this lesson, we're going to start building an Ansible playbook that will install Grafana on our local system. Now, of course, we aren't going to stop at the local system. We are going to be installing on other systems in the future, but while we're learning how to get used to Ansible, we're just going to start here. Now, if you take a look at the Intro to Playbooks documentation, it's actually pretty comprehensive and covers a lot of bases, but for this first playbook, we're going to keep it pretty simple. As you can see, a general playbook is a collection of plays. So for instance, we've got web servers and then tasks that work under that, and then update DB servers and then tasks under that. Now, of course, we're going to be installing an application, not screwing with databases right now, but we've got a lot more on the way. So everything is written in YAML. As you can see, we've got our play, then we specify the remote user if there is one, and then we've got tasks, and of course here, ensure Apache's latest version, write the Apache config file, etc., etc. So anyway, let's move on and start writing our own instead of reading documentation all day. So what we're going to do first in this lesson is we're going to scaffold out the playbook so we know exactly what needs to be done, and that's going to help us delve into the documentation and figure out which modules we need to use to deploy Grafana. This is how I personally go through all of my projects and how I recommend you do the same. It just allows you to organize everything very simply and make sure you don't miss anything. So what I'm going to do first is just open our user data file that we created before. As you can see, we've installed Grafana here. Now we're not going to bother with a host name right now, but the rest of this we need to do with Ansible. So let's go ahead and create a new directory. We're just going to call that playbooks, just like so. And a new file, and let's just call that grafana.yml, just like so. We'll open that, and let's actually split this screen here. And I'll drag the terminal down a little bit, we don't need that yet. And now what we can do is we can take a look at the tasks that need to be done and figure out how to design our playbook to get this done. So first of all, what I'm going to do is add this fun little header here with just 3 dashes. And that indicates the start of the file. And then we're going to start next with a dash and name, and this is going to be the name of the play. And this play is going to call install Grafana. Now we'll only stick with one play for this one, but we'll move into more later, of course. Now the hosts, we're going to use our inventory file, and as you remember, in our inventory file, we set up a group called hosts. So hosts actually specifies what we want to run our playbook on, and this host is the group host. So do know that this is not always going to be hosts. So if we have main servers, or Atlanta servers, or New York City servers, this could be different. It could be the Atlanta group, for instance, just like so. But in our case, we just named it host within our inventory file. Now next what we want to do, remember, apt requires us to become root, or to be a pseudo user. So we're just going to add become yes, just like so. Alright, now following that, we need to add our tasks. And be very wary, white space here matters, this is YAML. So make sure that all of your white space lines up. So under tasks, we then will add a name. First thing we need to do is download our apt key. And we've done that plenty so far in this course. Now in our case, we've actually already installed these, so we're not going to worry about that here. But for other nodes, you may want to, and we might add this later. But for now, we're not going to worry about it. The next thing is we need to add this apt key. Now as you can see, the way we did it with bash is we ran a wget to download the key and then added it using apt key. So if I head to the documentation and I take a look at my apt key Ansible built-in module here, and scroll down, we can see that it already asks for the file or the URL, so we actually don't have to run that wget. So as you can see here, Ansible built-in apt key URL, and we can just provide a URL. Now of course ours is going to be very different, but it's essentially pretty straightforward. And of course we will do that on an upcoming lesson. Right now we are just scaffolding this. So download apt key, just like so. Now the next thing we're going to need to do is we need to add Grafana to our sources.list right here. And luckily, we have an app repository module that we'll use for that. So let's go ahead and add Grafana repo to sources.list, just like so.
Kalau ansible be edible. Ansible service like ansible in AWS. Oh, berarti CloudFormation. Nah, ini seru banget deh.
Update the apt cache and install Grafana, just like so. So update apt cache and install Grafana. And I'll capitalize this too. I think they deserve capitalization. And then finally, what we need to do is ensure that the Grafana server is started and enabled. Now for that, we'll use the systemd module. So let's just go ahead and add that. Ensure grafana is started and enabled. Alright, so now we have our playbook scaffolded right here, which is great. It's going to make the rest of the lessons a little bit easier and a little more straightforward for us to start building out this playbook. So go ahead and mark this lesson complete. Come on back to the next one, and let's start building.
Oh. Okay. Interesting enough. Sini kita buat view baru, hanya playbooks. Di dalam playbooks kita namanya grafana email. Oke. Ups. Seru banget ya. Oh, iya sih, ini tuh apa namanya? Bakal berguna. Iya sih, ini mau nggak mau bakalan jadi tuh orang yang beda nih. Enggak lah itu ya, kalau misalkan orang mau masuk juga ini kan mati anjir, udah nggak ada, udah destroy, terminated semua. Nggak ada lah, mati semua. Oke, kayaknya sekarang udah sih inti belajarnya. Sekarang ya tadi kita ngedeploy ini resource AWS instance, juga user filenya, terus juga berhasil untuk ini bisa mendeploy Grafana tadi berhasil, dan juga tadi udah mulai perkenalan untuk menggunakan ansible. Mungkin next session kita akan coba menyelesaikan apa yang harus diselesaikan sama deployment Jenkins juga berarti ya. Oke, thank you, bye bye.